Chemistry students. So in our last lesson, we talked about atoms, and we talked about John Dalton, and that there's different kinds of atoms, and that those different kinds of atoms can join together to create compounds. And today what we're going to talk about, we're going to go ahead and we're going to talk a little bit more about atoms, but we're going to talk about the parts that make up atoms. Because those parts that make up atoms, they determine what the element's properties are going to be, and they determine how those atoms can join together to make compounds and all kinds of different stuff. So these parts of the atoms are going to be very important for us to understand going forward in chemistry. So let's go ahead and talk about some of those things. We're going to talk about the parts of atoms, what are called subatomic particles. And our target for today is to be able to identify and describe the different parts of atoms. There are lots of different kinds of subatomic particles, but there's three that are going to be relevant for us. So in this video here today, let's talk about the three different kinds of subatomic particles that are going to be important for us to understand in our chemistry class. There's the proton, the neutron, and the electron. And first, let's talk about the electron first. The electron is going to be probably the more important one for us for a good portion of our class. So let's talk a little bit about electrons first. Towards the middle of the 1800s, scientists had been playing around with what are called cathode ray tubes. Let's take a look at what a cathode ray tube is real quick. Okay, this is a cathode ray tube, right? All it really is it's a glass tube. It's got most of the air taken out of it. It's got a little white screen in the back so that you can see what's going to happen a little bit more easily. And then on each side, it's got an electrode. And then I've got some stuff back here that's going to help me put a high voltage across this cathode ray tube. Now watch what happens. Alright, once I've turned it on, I've put a high voltage across this, and you can see this beam appears going across, right? And this beam is a little bit weird. You know, scientists in the 1800s looked at this, and you might say, oh, it's just a beam of light. Not that big a deal, right? But what they observed is they observed some things here that are not like how light behaves. See, here I have a magnet. I can take my magnet and I can bring it close to the beam, and you see what happens. My magnet moves the beam. I can move the beam with my magnet. And that is not how light behaves. So in the middle of the 1800s, scientists playing with these said, there's something odd here. This is something we haven't seen before. So for decades, scientists were kind of, puzzled by this beam that appears inside of a cathode ray tube like that. And I'm not going to tell the whole story. It's a long story. Many, many years. Many scientists did many experiments. But one of them, towards the end of the 1800s, the beginning of the 1900s, by the name of J.J. Thomson. J.J. Thomson was a very famous English scientist. He finally explained what this beam was. Taking all of the experiments that people had done and thinking about the results, he found that this beam was made out of particles that were very, very, very small. And when I say that particles are very small, I mean they're much smaller than atoms. At this point, atoms were probably the smallest thing that anybody had ever even conceived of. And now here we've got a beam that's made up of things that are even smaller. And these particles that weigh, thousands of times less than atoms, and they had a negative charge. And J.J. Thomson realized these particles must be a part of the atom. They're smaller than the atom. They must be a part of the atom. And so they were called electrons. Electrons are a part of the atom. They are many, many times smaller than the atom itself, and they have a negative charge. And so before the electron was discovered, people kind of had an idea that the atom looks something like this. Just a sphere, a featureless sphere, right? But now here J.J. Thomson discovers there's a part. You can break it down into smaller parts. If you remember, we talked about when we were talking about Democritus and the original idea of the atom. The word atom comes from the Greek word for indestructible, right? So like you can't break it down into smaller parts. But now here, we can now break the atom down into smaller parts. There are parts of the atom. So now, rather than just this featureless sphere, now J.J. Thomson comes up with a new concept of what the atom looks like. And he thinks it looks something like this, where we have most of the sphere as a positive charge, and then there are little electrons here and there that have a negative charge. So if the electrons have a negative charge, then the rest of the sphere has to have a positive charge to balance it out. So he figured we've got a positive sphere with little bits of electrons here and there. Right? This was called the plum pudding model. I know we don't eat plum pudding, but apparently at the time and the place, plum pudding was like a common dessert, and it was like, I guess, this featureless, I've never had it myself, but I guess it was this featureless stuff with bits of plum, I guess, in it. I don't know, I've never had it. But so the picture of the atom that he comes up with looks kind of like this plum pudding. So it's called the plum pudding model, right? So the story of the discovery of the electron is actually much bigger and much more complex, but I'm not going to go into the whole story. Just the points I want you to know: J.J. Thomson, discoverer of the electron, and then some key features about the electrons that we should know. The electron has a negative charge. It is much smaller than an atom. It is very light. It's the lightest subatomic particle that we're going to talk about. And we can fairly easily tell how many electrons are in each different kind of atom. If you look at the periodic table in the box for each element, you'll see a big number. It's called the atomic number. This atomic number tells you a few things about the atom, right? It tells you how many protons are there, and we're going to talk about protons in a minute, but it also tells you how many electrons are in that atom. So if you want to know how many electrons are in, for example, an atom of carbon, you look at the periodic table and you see the number there is 6. That tells you that an atom of carbon has 6 electrons. The next big discovery about what the atom looks like was actually not the discovery of one of the particles that we're going to talk about. Remember, we're going to talk about electrons, protons, and neutrons. But the next big discovery was the discovery of what's called the nucleus, right? The nucleus of an atom is the middle part of it, right? And there was a very famous experiment conducted by Ernest Rutherford in the early 1900s, late 1800s, early 1900s, somewhere in there. It's called the gold foil experiment. I can't actually show you the gold foil experiment. It involves radioactive materials and gold foil and stuff like that, but it's actually a really cool experiment. I'm going to put a link to a video that will describe the experiment for you. But in his gold foil experiment, Ernest Rutherford found that most of the mass of an atom is actually concentrated in a very small part. So the actual part of the atom that weighs something, that gives it almost all of its weight, is actually a very small part of the atom, right? And so we get a different model of the atom now. Rather than just this sphere with electrons in it, like in the plum pudding model, now what we have is this nucleus, this little bit in the middle, where almost all the mass is, with the electrons scattered around outside of it. And so you can see in this model, it's a really cool thing to think about. The atom is actually mostly empty space. Alright, so the discovery of the other two particles that we're going to learn about here today, protons and neutrons, I'm not going to go into the whole story about the discovery of them, but it's much longer and involves lots of people. The proton, some key features that we need to know about them. Okay, both protons and neutrons can be found in the nucleus. So they're concentrated, they're all together in that middle nucleus part of the atom, right? And the electrons are around the outside. The protons have a positive charge. They're what gives the positive charge in the atom. So the electrons are negative and the protons are positive. And the protons, they have a mass of, we're going to say their mass is 1. The neutrons have no charge. right? And they also have a mass of 1. So a proton and a neutron weigh about the same, and an electron weighs much, much less. The proton is positive, the electron is negative, and the neutron has no charge. You can tell how many electrons there are by looking at the periodic table. You look at that number in there, and that tells you how many electrons. Now later in the class, we're going to talk about when atoms don't have the right number of electrons. It happens, and it's going to be very important for us understanding chemistry, but that's going to be a later unit. For now, let's just say atoms have that number of electrons that you see on the periodic table. That number also tells you how many protons are in the atom, right? So for example, carbon, if we look at carbon, you see its number there is 6. We call that the atomic number. Its atomic number is 6. So that tells me it has 6 protons. It has 6 electrons, right? How many neutrons does it have? Well, I cannot easily look at that and tell how many neutrons it has. Atoms can have different numbers of neutrons. Carbon, for example, it could have 6 neutrons. It could also have 8 neutrons, right? They can have different numbers. Atoms of that same element that have different numbers of neutrons are called isotopes. We'll learn more about isotopes later on. But for now, we can't easily tell how many neutrons there are in an atom. So let's say I have an atom that looks something like this, right? What can we tell about this atom here? Let's take a look at it. I've got some particles here that have minuses in them, and those particles are the electrons. We look here, I've got 1, 2, 3 electrons in my atom that I've drawn. If we look in here, this part is the nucleus, right? The nucleus is that middle part that has the protons and the neutrons. And you can see I've drawn pluses inside of the protons because they have a positive charge. And if you see, I have 1, 2, 3 protons in there, right? We should have the same number of protons and neutrons in our atoms. And you can see the little bits here that I've drawn without anything inside of them, those are the neutrons. So you can see my atom that I've drawn has 4 neutrons in it. 1, 2, 3, 4. So can I say which element this atom belongs to? Well, it's got 3 protons and it's got 3 electrons. So its atomic number is 3. So let's go to the periodic table and let's look at which element is atomic number 3. That element is lithium. Lithium is atomic number 3. So this atom that I've drawn here is a lithium atom. Another thing we might want to talk about is what's called the atomic mass. The atomic mass is the weight of the atom, pretty much, right? And when we talk about the weight of the atom, we talk about it in what are called atomic mass units. An atomic mass unit is how much a proton or a neutron weighs. And then however much the electron weighs is so much less than a proton or a neutron, it doesn't matter, right? We just don't count it. So basically, for the atomic mass, all you have to do is count up protons and neutrons, right? So protons and neutrons, how many do I have in my atom? 1, 2, 3, 4, 5, 6, 7. So the atomic mass of this lithium atom is 7 atomic mass units. How about this atom right here? You can see in this atom I've drawn my electrons in 2 different circles. It's called energy levels. We'll learn more about them a little bit later, right? Let's see, how many protons, how many electrons, and how many neutrons do I have in this particular atom right here? I have 1, 2, 3, 4, 5, 6 electrons. If you look inside the nucleus here, let me count all the protons, the pluses. 1, 2, 3, 4, 5, 6 protons. Remember, I should have the same number of protons and electrons. Here I have 6 of each. What about the neutrons? Here I have 1, 2, 3, 4, 5, 6. So I also have 6 neutrons. Doesn't have to be the same number, just so happens to be the same. Okay. So which element is this particular atom right here? Well, with 6 protons and electrons, let me go to the periodic table and look up atomic number 6. And that's carbon. So this particular atom here is a carbon atom. Can we say what its atomic mass is? Remember, atomic mass is how many protons and neutrons it has. Well, there were 6 protons and 6 neutrons, so together there's 12. So the mass of this atom is 12 atomic mass units. Okay, so there's a little bit about our subatomic particles. We've talked about electrons and protons and neutrons. We've talked about the nucleus, the atomic number, the atomic mass. We've talked about how to tell how many of each subatomic particle are in an atom of each particular type of element. Hopefully that helps us to be able to identify the different parts of an atom and the properties of each part. So until next time, take it easy.